welcome to Accurate One. In this session, we're exploring the basics of programming, starting from the ground up. Imagine programming as giving instructions to a computer, a machine that can process data, make calculations, and follow steps to produce results. Think of a computer as a black box, something mysterious from the outside. When given an input, it processes this information internally and gives us an output. What's inside this box? A lot of complex components that work together to handle our instructions. Programming is about telling this black box what we want it to do by writing code. Inside the black box, the CPU or central processing unit acts as the brain of the computer. It interprets and processes instructions from our programs. Every time we write a line of code, the CPU executes it, handling all kinds of tasks, from simple calculations to complex operations. Essentially, it's where the magic happens, translating code into actions. Next, let's talk about storage. Storage holds the data and instructions that the CPU needs to perform tasks. Think of it as the computer's memory, where it keeps information long-term, like on a hard drive or SSD, or short-term, like RAM. When we program, we often work with the stored data, whether saving, retrieving, or modifying it. Many programs need to connect with other computers or devices. This is where networking comes in. Through the network, computers can share information, send and receive data, and communicate with each other. Networking lets us expand the capabilities of our programs, allowing them to interact beyond the local machine. Finally, the operating system. This is the software that manages everything inside the computer. It's responsible for managing resources like CPU, memory, and storage, ensuring that programs run smoothly. The operating system is a bridge to the computer's hardware, making it easier for us to interact with the black box. In this example, we feed in raw binary data, a sequence of ones and zeros, which is how computers actually understand instructions. This binary data goes through complex processes within the black box, and in the end, we get a meaningful output, like displaying the text "Hello World" on the screen. However, writing code in binary isn't practical or human readable. This is why we use programming languages. They allow us to write instructions in a way that humans understand, and then the computer can translate these instructions into binary code. Programming languages bridge the gap between human logic and machine execution. Let's take a look at the current popularity trends in programming languages. As we can see, Python leads by a significant margin, being a preferred choice for various applications from data science and machine learning to web development and automation. C++ and Java follow, showing their continued relevance in systems programming and enterprise solutions. Languages like C, C#, and JavaScript also hold strong places, each catering to specific fields and communities. Python is a versatile language with applications across many fields, making it a valuable tool for developers and industries. In a cybersecurity, Python is used to create scripts that detect and mitigate security threats. For Internet of Things or IoT, Python helps manage and analyze data from connected devices. In blockchain, developers use Python to create secure, decentralized applications. Python also supports game development, allowing developers to build engaging and complex games. For desktop applications, it helps create GUI interfaces. Cloud computing relies on Python for scalable applications, while automation scripts simplify repetitive tasks. Python's strong support for machine learning and artificial intelligence makes it essential for creating intelligence systems. It's also the go-to language for data science and analytics, helping professionals derive insights from big data. Lastly, in web development, Python framework like Django and Flask power dynamic and robust websites. You need to know you can't create these apps just by knowing Python. You need to know the basics of each subject. What are the concepts, what are the topics, and what are the important information from each subject. To sum up, Python's versatility makes it a leading language in many fields. Let's quickly recap why Python is so widely used and valued. Python is used across various domains including cybersecurity, data science, and automation. Its simplicity and flexibility allow developers to quickly build prototypes and adapt to different projects. Python has a vast ecosystem of libraries, modules, components, and supportive community, making it accessible and powerful for new and experienced developers alike. So, here it is. That's why we use programming languages, and in the next lesson, we're gonna hands-on by setting up our programming environment so we can start writing Python code. See you then.